Welcome to an example in which we are going to find the distance across a small lake. So specifically, we're trying to find this distance right here from A to B. Right? It says find the distance across the lake using this information. So how do we find this distance from A to B? So basically we want to find this side of the triangle over here. Call this X. I want to find that. Well, first off, let me write up here. It's not a right triangle, so we cannot use SOHCAHTOA, can we? That's only for right triangles. Also, we don't have any side and opposite angle. Any side with its opposite angle. Right? Do you see that? So we cannot use law of sines. Therefore, we're going to have to use law of cosines. So let me make sure you see that. Here we have this angle, but we don't have the side opposite. We're just calling it x. We don't know it. We have this side, but we don't have the angle opposite. We have this side, but we don't have the angle opposite. See how we don't have any side with its opposite angle? If we did, we would just use law of sines because that's easier. If we had a right triangle, we would use SOHCAHTOA. If we had a side and angle pair, opposite pair, then we would use law of sines. We don't have either of those. We must use law of cosines. Okay, so we're going to have to use the law of cosines. So how are we going to use law of cosines on this one? Well, it's not here actually. Let me add it in here. Oops, that was a mistake. Let me try that again. Okay, let me add in here the law of cosines. There it is. Make it a little bigger. Okay, here's the law of cosines. This is from the notes. This is from the chapter 10, 1, 2, and 8 notes, law of cosine. So there's three versions of the law of cosine. Remember, in the law of cosines formulas, the different versions, they assume A is across from A, B is across from B, and C is across from C. So A is across from A with B and C in between, or B is across from B with the other two, A and C in between, or C is across from C with A and B in between, right? That's how the law of cosines works. So basically you have a side and the opposite angle. Side, opposite angle, with the other two sides in between. So you can use any of those versions. So I'm going to use, therefore, on this one, this side opposite angle. So what am I going to call them? So I'll call this, in fact, why don't I call it C, because it's across. See how it's across from C? And then this will be A over here, and this will be B right here. Why am I doing that? Because A is across from A, B is across from B, and C is across from C. Okay, so which of the versions? Well, what am I trying to find? C, right? So I'm going to use that version of the law of sines. So C squared is A squared plus B squared minus 2 times A times B times cosine, get this out of the way here, times cosine of capital C. This is A equals on the side. Okay, so there's what I'm going to use. So that'll be C squared, which I'm trying to find. Whoops. C squared, which I'm trying to find, equals A squared, which is 1.77 squared, plus B squared, 2.19 squared right there and right there, minus 2 times A, 1.77, times B, 2.19, times the cosine of angle C, which is right there, 43.6 degrees. So basically, hit the buttons on your calculator. I'll bring it down here. I'm just going to do that myself. Make sure you are in degree mode, right? Because that's a degree angle. I'm going to check my own mode. Yeah, I'm in degrees. That's a degree angle. Okay, 1.77 squared plus 2.19 squared minus 2 times 1.77 times 2.19 times the cosine of 43.6. I'm getting 2.314785. Now that's c squared, so I got to root it, and get my value for c. I'm going to hit second square root. I use my answer button. It's quicker, don't have to retype it. 1.5. How many decimals do they want here? 2. Okay. 1.52. C must be 1.52. So we're able to find C by using the law of cosines. Because we didn't have any side and opposite angle, we couldn't use law of sines. So C equals 1.52.